STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Dr. Eric Smith.
Hello, everybody, and welcome to this week's NASA STEM Stars, where we use this opportunity to engage and converse with professionals from all around the country that work at NASA, and we get to hear more about their background, their education, and the current missions that they're working on. I am so excited about this week. We have a program scientist from the James Webb Space Telescope with us today, and I cannot wait to hear more about his work. But before we get started, let's talk about real quick how this episode will go. We will be exploring Dr. Smith's background, his education, his current work on the Webb telescope. You get a chance to ask your questions. We'll learn about next week's episode, and I will also challenge you on an activity at the end of this episode. So feel free to drop your questions in the chat box. And without further ado, let's go ahead and get started. So welcome, Dr. Smith. How are you today?
Great, thanks. Glad to be here, Jennifer.
Yeah, thanks for being with us. I am super stoked to hear about your project. I'm kind of geeking out. I love the Webb telescope. Hubble was great, but man, is Webb going to be greater. So why don't you tell us a bit about how you got to where you are and what you're interested in, all that good kind of stuff.
Okay, sure. So I'm an astronomer at NASA headquarters, and I've always been interested in space. Part of that just comes from when I was growing up, but I'll get into that a little bit later. But the picture you see of me here, I'm sitting at the bottom of what everyone imagines a telescope looks like. This telescope was actually built in 1893. And when I was an undergraduate, I did work on this telescope here. It's at the Leander McCormick Observatory in Virginia. I actually took photographic glass plates with this telescope. But I was interested in astronomy for a long time. And like I said, we'll get into more of that. In these COVID times, one of the things that I've always loved to do, I've been doing for 40 years, 30 years with the last team, was play softball. And I haven't been able to do that this summer. So it's one of the things I've been missing in the COVID world.
How did you get interested in astronomy? Did you have like a middle school teacher, or you're just as a kid? What happened?
Well, a lot of it stems from when I was growing up. I was growing up in the 60s and therefore a child of the Apollo era. So Apollo was in the news. We were seeing the astronauts. Here you can see down there on the bottom left of the screen, the 3 astronauts from Apollo 11. They were going to the moon. Of course, in popular culture, Star Trek was really big at that time, the original series. So I watched all of that. And that's what really got me interested in space. And from there, I wanted to be an astronaut, of course, but that led me to actually think more about space. And so then I ended up going to school, the University of Virginia and the University of Maryland, and there started going to ground-based observatories and actually making these observations. And once you've been to an observatory and you've seen that night sky, it's hard not to become an astronomer.
I've actually had the pleasure of doing that as well. Once you use a very powerful telescope and you look through that eyepiece and the moon is right in your face and you see the craters and just gazing up at night and you realize how vast it is above you. So I totally get that excitement that you had when you went to school and became an astronomer for NASA. So when you went into college, did you begin pursuing astronomy right away, or did you go in and dabble in all of the sciences?
When I started out, I knew I was interested in some sciences, and I had to take chemistry and I had to take physics, and my focus on astronomy came a little bit later after I had taken some of those introductory courses and decided, well, thinking back to when I was a young boy, the stars were calling. And so it was the background in all of science that's really important. And it's one of the things maybe I'll talk about later at NASA. There are all kinds of scientists that are employed. So it's not just engineers and astronomers. We have biologists and chemists. It's really interdisciplinary science that the agency does now.
So how did you get a job at NASA? Did you right after you attended the University of Virginia, or did you continue on to pursue your master's and then came in that way?
So when I was working for my PhD at the University of Maryland, it's about 5 or 6 miles from the NASA's Goddard Space Flight Center. And I did some work at Goddard while I was still a student at Maryland, met some of the scientists out there. And so right after graduating, I went to work with some of them. And then almost left NASA twice. I had another offer to go to Canada for a job and an offer to go to the Netherlands for a job. But both times the offer from NASA was better. So I ended up staying with NASA.
I bet you're glad you did too.
Oh, certainly. Yeah.
Yeah. So tell us, what is it like being an astronomer at NASA? What kind of projects do you get to work on?
When you start out as an astronomer, and here you see some pictures from maybe different phases of my career, at Goddard, you're a research scientist, so you're doing some of your own research, but you're also enabling others to do research with NASA facilities. And now that I'm at headquarters, it's more about enabling the broad community. But I've had the chance to work on the shuttle program with telescopes in the shuttle. You saw me there with a web mirror. And then that last picture was recently out at the Griffith Observatory where I was giving a talk about Webb.
Okay. So you said you worked on the shuttle program. Can you tell us a little bit about that? Were you involved with the Hubble telescope at all?
I was the program scientist for the Hubble Space Telescope during its last servicing mission. And so I got to go down. This picture is of that launch for the last time they serviced it. And it was fascinating to be on the consoles, hearing and talking with the astronauts as they were fixing the telescope. And prior to that, I worked on a much smaller telescope that they would just sort of stick up out of the bay of the shuttle. And it was up for 2 weeks. And that was also fascinating, but not nearly as famous as Hubble.
So you work actually at Goddard, right, in Maryland. But if you were working on the console, then you must have been down at Johnson Space Center, correct?
For the Hubble mission, I was at Johnson Space Center because that's where they were controlling that from. For the other telescope I talked about, its name was the Ultraviolet Imaging Telescope. That payload was flown or operated out of Marshall Space Flight Center in Huntsville, Alabama. So they actually have a much smaller version of what they have at Johnson there in Huntsville. So I got to visit both places. So that was cool.
Yeah, so as I was going to say, so you worked at NASA at Goddard, but you get a chance to go to several of the other centers around the country because we actually have 10. So
right.
You probably have had a chance to explore a lot of those different centers through your career at NASA too, right?
That's right. The work that science does involves most of the centers. The only center I haven't had a chance to visit yet is the one called the Stennis Space Center, where they actually just build the rockets that NASA builds. They don't really have a science program there, so it's that one's on my bucket list. I have to go down there, figure out a reason to go down there.
So we have a question from a student that wants to know, where's the best place to go if you want to stargaze? So they're particularly curious about Tennessee, but I'm sure that there is general rules that you want to find a certain kind of location if you're really interested in stargazing. So maybe you could tell the students a bit about what kind of location they want to look for.
Sure. The best thing you can do is find a place where you're away from city lights or any kind of street lights. So if you're, it's a little bit harder if you're on the East Coast. If you're in Tennessee, I would encourage you to go to the Smoky Mountains because the skies around there are very dark. Of course, some of the best skies in the U.S., the continental U.S., are in the Southwest, where it's very dry and there aren't as many people, so the skies are very dark. On the East Coast, you have the lights, and also there's a lot more atmosphere. You're lower altitude, and that tends to block out the stars. But the best thing is sort of get away from the city lights or any street lights and let your eyes adapt. Go outside, stay outside for about a half an hour, and your vision gets better for seeing things in the dark.
Is temperature important as well?
Usually, the cooler it is, the better it is, because the atmosphere is more still, and so the stars twinkle a little bit less. It's best when it's very cold, but it's also uncomfortable if it's very cold and you're outside.
And I know when I was stargazing when I was younger, it was helpful to have a red flashlight when I was using the star charts and things, because then you're not, doesn't change your vision once you've adjusted or adapted to that nighttime. So yeah, red lights are cool.
Yeah, back in the days when I used to go to ground-based observatories, there in the control rooms, we would often have just the red lights on, so that if we needed to go out into the room where the telescope was, our eyes were already dark adapted.
Yeah. So, well, let's get back to talking about your work at NASA. So you're currently at Goddard working with the Webb telescope. So can you tell us a bit about what it's like to work at Goddard and the team that you work with?
Okay, well, I started my career at Goddard, worked there for about 11 years, but now I actually work at NASA headquarters. Even though I'm working still on the James Webb Space Telescope, it's from this different perspective of headquarters. Now, NASA Goddard and NASA headquarters are only 10 miles apart. Headquarters is downtown in Washington, D.C., about 2 blocks from the Capitol. Of course, I haven't been there for about 6 months because we're all working remotely now. But working at headquarters, it's a little bit different. You're not quite as hands-on with the hardware, but you deal more with the policy of how the telescope will operate and who will use it and how it will work. So there on the left, you see, now that's a picture of when I just went down to NASA headquarters. That was the group I started working with. I'm not in the picture because I'm taking the picture that time. But you can see it's a very diverse group of folks, and it was a blast to work with that Dr. Ann Kinney, the redhead in the front right there with the shirt. She was the leader of that group, and that was a blast just coming down there and seeing all the missions that NASA works on. What you see there is a picture of NASA headquarters, the building in Washington, D.C. It's primarily just an office building, not super exciting. Because it's office work, if you can go to the next slide, sometimes your day can feel like this because you're dealing with a lot of policy and budgets things and how they affect the science. But for me, even when the days feel like that, if you go to the next slide, I know it's worth it because in the end, this is the product that we generate. And while I may not be taking those pictures, the stuff that I help build helps other people do it. And that's what keeps me jazzed about going to work.
That's awesome. I love it. That quote kind of reminded me of the Star Trek, where you boldly go. So were you a big science fiction fan growing up as well?
Yeah, read a lot of science fiction. Of course, when I was growing up, it was really sort of before the fantasy era, so it was a lot of what we now call hard science fiction, a lot of technical stuff, not so much on the character development, that was always a little lean, but I think that was part of where my fascination with technology and how things go together, and you saw maybe in that first slide, I love when something breaks in the house, it's almost more fun for me because then I get to take it apart and see how it works and see if I can fix it.
Oh, I'm sure a lot of students can relate to you about that one for sure. So our next question actually kind of leads us into our next conversation that we're going to have. They want to know what kind of discovery you're most looking forward to with the Webb telescope. So if you would like, maybe we can move into a portion of the episode where we'll talk a bit about the Webb telescope.
Sure, that'd be great.
Sure. All right. So I think we have a first slide. Yep.
Yeah. Okay. So so this is sort of your normal opening slide, but I do want the people who are watching to take note of the shape of the telescope there. And you see, that's our space telescope, James Webb Space Telescope, and it looks very different from that first telescope you saw me sitting on, the big long tube. And that's what people think of, kind of a tube. And we're very different. And maybe we can talk about why we look so different. If I could have the next slide, what a lot of people will ask me is, okay, who was James Webb? Why is this telescope named after him? Now, James Webb wasn't a scientist. He was actually a lawyer by training, and he was NASA's second administrator back in the early 1960s. And he was the person who put together the Apollo program that took us to the moon. Again, you might say, well, why is a telescope named after a lawyer who did manned spaceflight or human spaceflight? It was because he recognized how important it was for science to be done at NASA. And the fact that the only reason there is science is because he insisted on it. At the time, President Kennedy didn't really want it. So it's fitting that the telescope's named after him. Now, maybe if we could go to the next two slides quick. I'll just say the reason why we built it. So everybody may be familiar with the Hubble Space Telescope. And again, that looks like this, kind of like a tube. And it took the picture on the next slide, which was the deepest picture of the universe ever taken. And when this part of the sky, if you were to look at it with your naked eye, or even a big ground-based telescope, would be totally blank. And when Hubble took this picture, you can see it's filled with galaxies. Importantly, none of these galaxies were the very first galaxies to form after the Big Bang. And so that's why we're building Webb, is to see those first galaxies that Hubble couldn't find, as amazing as Hubble is.
Well, explain that. So you said we'll see the very first galaxies. What do you mean by that?
After the Big Bang, the universe was just a hot sea of protons and electrons, pretty much. There were no stars, there were no galaxies, there were no planets. As the universe began to cool and atoms could form and material could clump together, it eventually formed stars and galaxies. We haven't seen those yet with Hubble. They would look very different. We have theories of what they would look like, and we know we needed to build a much bigger telescope that worked in the infrared part of the spectrum to see those galaxies. And that's what Webb is. It's bigger than Hubble, and it works in the infrared, or the heat part of the spectrum.
Can you explain to students why, if the galaxies in the universe formed so long ago, how can you use a telescope today and see something that happened so very long ago?
That's a great question. When the light left these galaxies that were forming, it's traveling through space, and space itself is expanding. We know we live in a universe that's expanding, and most of the space is empty. It's space. And so that light that left those galaxies is being stretched out to the redder part of the spectrum, the infrared, and it's traveling for about 13.5 billion years to get to us. And so by looking for very far objects, we're also looking back in time. So that's why we sometimes call telescopes time machines.
That's very interesting. I'm sure that's going to grab some attention from some of these students thinking, wow, we can actually time travel with a telescope. It's amazing.
Yeah.
Yeah. Okay, so your next slide, you've got a picture of, it looks like a sun or maybe a star. Can you explain that one to us?
Actually, there should be a little movie that I'd like to run. What this depicts is how the universe formed some of those early galaxies. And so you can see it's a computer simulation. The material in blue is what we call dark matter. It doesn't emit light. And the brighter objects are huge clusters of galaxies that are forming. Down on the bottom, you'll see a little thing that says redshift clocking along. That's measuring how close we are to today. Today is a redshift of 0. And if you look at those little clumps, you can see action going on inside of them. That's galaxies beginning to form. And so scientists will use Webb to take snapshots through time to more or less build up a statistical picture of how galaxies formed throughout the history of the universe. There won't be one single first galaxy. We'll do this by taking pictures in many different directions and building up, like I say, a statistical sample of what the universe looked like long, long ago, and then in between. So we can basically watch the universe evolve from when it first made galaxies to today when we can see them nearby. And this is a big supercomputer simulation.
It's beautiful.
Yeah,
so we
I've
had
often
a question while we're watching this. What's the most amazing thing you've ever seen with a telescope?
The most amazing thing I think I've ever seen are work that I did when I was studying galaxies that collide. So these are, it's actually beautiful when you see two of these spiral galaxies, huge dinner plate looking things, and they collide and they throw off these wisps of material. Those have always really impressed me. Later on, I don't have a picture of an interacting galaxy, but I have a picture of interstellar space within our own galaxy from Hubble. And again, those are just absolutely beautiful. But if I think back to my very first telescope that I had as a boy in my backyard, just seeing the moons of Jupiter blew me away. That was very cool.
Yeah, just to be able to see that from your backyard, that's pretty awesome.
Mm-hmm.
So, okay, so tell us a little bit more about Webb. When are we launching? How's work going with it? I know we've all been anxiously awaiting the launch of
Mm-hmm.
this telescope. So, can you tell us more about the timeline?
Sure. Right now, the telescope is all built, and we're doing what are the final tests of it in Southern California, actually at a plant there, Northrop Grumman, a place called Space Park, just in Los Angeles. And once those tests are finished, we will launch in October of next year. Webb is a partnership with the European Space Agency and Canadian Space Agency. And actually, Europe is going to launch this for us out of their facility, which is in French Guiana in South America. So next October, it will be down there when it launches into space.
So, did I hear you were taking a vacation to South America next October? Is that what you said? That's going to be a pretty cool launch.
It should be. The facilities there, they're not like they are down at Cape Canaveral or Kennedy Space Center where you work. There, things are set up for the public to really be participating and see it. It's much more remote at ESA's site. So even when you're in the launch room, you're about 11 kilometers away from the actual launch site, and you just see the rocket come up over the trees. So you don't even get to see all that fire and smoke on the pad.
Still, it's going to be a proud day. It's almost
Oh,
like
definitely.
watching your child leave for college. You're just finally
Exactly.
there it goes, and then you'll get all that new data. Tell us. I know you have a couple more slides you wanted to share with us.
Sure.
Yeah.
So we know that we designed Webb to look for those first galaxies, but we also know that astronomers are going to look at exoplanets, planets that orbit other stars. And so what you see here is an artist's conception of one of those planets in front of another star. So what Webb will do is look at these stars with what's called a spectrograph. And think of a prism that splits up light into a rainbow. We use the same kind of thing on Webb. And as it splits up the light of the star, and then the star with the planet in front of it, we'll see differences. And that will tell us about what's in the atmospheres of these exoplanets. So we'll get the chemistry of exoplanets. And I like to say we will be able to breathe, in some sense, the atmospheres of alien worlds someday once Webb is launched.
That's
But
well
we know
said.
astronomers do that. Yeah.
We had a question actually about exoplanets. You must have read their mind. They're interested in projects or upcoming events of finding exoplanets. So, is there a place, do you know, that the student could go and find out about these events, or how do they find out about the projects for exoplanets?
So The Exoplanet Center for NASA is at the Jet Propulsion Laboratory, and they have what's called the Exoplanet Exploration Program is run out of there. And so if you were to just go to jpl.nasa.gov on the web, I'm sure you would find links there to all the exoplanet work that the agency is doing. We have a mission right now called the Transiting Exoplanet Survey Satellite, TESS, and it is discovering even more exoplanets. We know of several thousand at this point, which from my Webb perspective, that means I have a lot of good targets to go look at with Webb.
That's great. So the next picture on your slides, I love. It's so beautiful. Can you describe what we're looking at here?
Yes, this is, so these are nebula. These are clouds of gas and dust in space. And the glowing structures are gas. So this would be hydrogen gas, and it's lit up and it's glowing. And then the very dark, cloudy structures, those are just dust that's blocking the light from behind it. And in our own galaxy, it's inside these clouds of dust that new stars form. Another beauty of an infrared telescope is that it lets you see inside these clouds. And so Webb will look at places just like this to watch young stars and planets being born. This is another big area where Webb will make progress.
It's beautiful. And then that next picture with the planets, that I know that's our solar system, but surely we're not that close to the sun.
No, this is not to scale. Yeah, we would have a bad day if we were this close to the sun. This is just to show all the planets in the solar system and to say that Webb will make observations of Mars, Jupiter, Saturn, Uranus, and Neptune, everything on out, and their moons. Because of Webb's open telescope design, we can't actually look inward toward the sun. So Webb can't observe Venus or Mercury.
So I know Hubble is about 350 miles off the surface of the Earth. Where is Webb going to be located in our solar system?
So Webb will orbit the sun like the Earth, but Webb will be 1 million miles from Earth. So, and we put it so far away because it's this infrared telescope. It's looking for heat from distant objects. So we don't want it to be near the Earth. The Earth is a big hot object and it would heat the observatory. So we put it very far away just to keep it cold, and then it follows the Earth around the sun in its orbit, so we can always talk to it with our communications dishes here on Earth.
Do you think Webb will find more ocean worlds like Earth?
What Webb will do, it's a tricky question. Webb will more or less be used when people think they have an ocean world to confirm it or not. Webb's field of view, like Hubble's, is pretty small. It's not a good telescope to go searching for things. Once you know you have a target to look at, though, it's a great thing to study it in detail. So people will have theories about which are the best ocean worlds to look at, and those are the ones Webb will go explore.
So maybe the work that TESS is doing, then the Webb telescope could help. Is that what you're saying? So something like that? Okay.
Yeah.
So the next slide, I'm sorry, go ahead.
Oh, there was a satellite before TESS called Kepler. People may have heard of that satellite, and it too found thousands of exoplanets. So those two telescopes really are providing us with wonderful targets to go look at.
So I was going to say the next slide that we have has some of the Webb telescope social media. So if students want to follow the progress of Webb or probably even see the launch live when it occurs, I would encourage you to follow their Facebook and Twitter accounts. But there's also a mission overview video that we want to encourage our students to watch. It's about 4 minutes long, but it gives a really good overview or snapshot of the mission of the James Webb Space Telescope. Do you want to add anything to this slide that I haven't already said, Dr. Smith?
Well, I really would encourage students to go to that link there on the right of the screen. It's beautiful to watch the telescope coming together. It's the work of 29 states have been involved. Several thousand people were working on the program at its peak. This slide, the beautiful image you see there, was made for me by a student intern I had working with me this summer. You can see her name, Christina Beck, down there on the bottom of the slide. And actually, Webb has inspired quite a lot of artwork as well. If you go to the website for Webb, you'll see there's a section about Webb art. And because of the unusual design of this telescope, it's actually inspired a lot of artists to create things for it.
Yeah, Christina Beck actually appeared on one of our previous NASA STEM stars. So students want to go back and look at that. We actually had the intern panel that you worked with over the summer. So I encourage students to go back and watch that one too. It's pretty interesting. So that's about all the time we have. Do you have any final comments for our students today? Anything that you want to inspire them with?
So what I would say is, if you're interested in science and astronomy, of course, NASA is a great place to work. But NASA has people in it that do law and that do budgets and that do many other things. So if you're interested in space, it doesn't really matter what your particular focus is. We probably have a space for you at NASA. All you have to do is love space, and we would love to have you on the team.
Awesome. Thank you so much for being with us today, Dr. Smith. I hope you had as much fun as I did.
Oh, my pleasure. I enjoyed it.
So we want to challenge the students now. We have a call to action. There's an activity that I want you to check out. It's actually a really fun game. It's called Exoquest, which is about searching for exoplanets. So we had a question about that earlier in our chat. So I encourage you to go play that game. We'll put the link in the chat box. And then you can actually print out a certificate of completion when you finish your game. And you can check out the Exoplanet Travel Bureau posters, and you can print those off as well to decorate your bedroom or your classroom at school. And if you wouldn't mind, share your certificate on our social media account, #NextGenSTEM, so that we can see that you are just as involved in NASA's search for exoplanets as we are. And then next week, we've got another NASA STEM episode with Viana Cadenas, and it's about the Artemis program, and it'll be on the 24th at 1 o'clock. So be sure to tune in and make sure you hit that subscribe channel so that you never miss an episode of STEM Stars again. So thanks for joining us again, and we'll see you next time, STEM fans.